Hello everyone. So in the today's video lecture we will be discussing about common gate amplifier. So the circuit what you see here is the MOSFET, which is made up of drain, source and gate terminal. So in this common gate amplifier, the gate is common for both input and output. The input is given to the source terminal and the output is taken at the drain terminal, right? So this is the common gate configuration. So the input impedance of this common gate amplifier is very less. Usually this type of amplifiers for any in general, the input impedance of the amplifier will be very high, but for this common gate amplifier the input impedance is very less. So this type of amplifiers are used in the applications of low frequency applications, where the, like in the case of transmission lines or in the case of antenna, when you are receiving it from the antenna and giving it for the amplifier, so the antenna or the transmission line, the impedance of this will be very low. So if you have an amplifier with a low input impedance, such kind of amplifier will not cause any loading effect. So hence, so this common gate amplifier can be used for low frequency application. Okay, so this is the configuration, and the common gate amplifier circuit will be given as like this, which is the input is given to the source terminal and the gate is biased with a DC source, okay, and RD, and this is VDD, right? So this is the practical common gate amplifier, where we are giving the input Vs to the source terminal and output is taken at the drain terminal, okay, and corresponding to this Vs, and this VDC is the DC supply what we are giving to bias the transistor, bias the MOSFET device. So the RD is chosen properly such that the MOSFET is operating in a saturation region, that is constant current region. So for the AC analysis this will be connected to ground. So the we're going to analyze this for the small signal analysis using a small signal model. So this is gate terminal, so this is source and this is current GM into VGS, so this is drain terminal. So this is the small signal model for the amplifier MOSFET only. So now for this the input is given to the source terminal, so this is your input signal what you are giving, and the RD is connected from drain to VDD. VDD is connected to ground for the AC analysis. So this will be the small signal model, and the gate terminal is connected to ground, right? So this is the small signal model for the common gate amplifier. So first we will discuss about input impedance Zin. Okay, so the input impedance is given by the ratio of V in by I in. Okay, so this is the input signal what we are giving from the source, and I in is the input current due to input voltage, right? So now to find out the input impedance we will apply KCL to this node. Okay, KCL to the node A. Node A. So here this is the input current which is going to the node A, and this is the ID current which is going to the node A. By applying KCL to the node A, we will get I in plus ID is equal to 0, because all the currents are incoming to the node A. Okay, so this we can write it as I in is equal to minus ID. So where ID is nothing but GM into VGS. Okay, so here this is the input current. So here we can see that the source terminal is connected to the positive terminal of the input voltage, and the gate terminal is connected to the ground. So if we see that V in is from source to reference, similarly ground is also connected to the gate is also connected to the ground. So this VGS with respect to this can be written as V in can be written as minus VGS. Okay, because it is the same voltage V in from source to ground, and VGS is from gate to source, where the gate is connected to the ground. Hence V in will be same as VGS but opposite in sign. Okay, so substituting this in here, I in can be written as minus GM and VGS can be written as minus V in. So this can be written as I in is equal to GM into V in. So this can be written as V in by I in is equal to 1 upon GM. So V in by I in 1 upon GM, this will be the input impedance of the common gate amplifier, right? So this is about the input impedance. So to find the output impedance is nothing but the impedance Z0, which is between with respect to V0 and I0. Okay, so now here this is the output voltage from drain terminal. What we are taking the output is taken from the drain terminal to the reference. So now here when we are determining the impedance between any two terminal, where we call it as Thevenin's equivalent circuit, so all the other voltage sources will be connected to the ground. So here in this case, if we short this V in, so then what happens, the source is connected to the ground. So when the source is connected to the ground, VGS becomes 0. When VGS becomes 0, this GM into VGS will become open circuit, completely open circuit. So now what you have is only RD. Okay, what we have is only RD. Z0 is nothing but RD. So the output impedance will be equal to RD. So if we consider the channel length modulation, for which we have an impedance R0 connected from here to here, so this is again connected to the ground. So in this case what happens, this RD will be parallel to R0. So since R0 is very large, so Z0 can be still approximated to RD. So the output impedance of the common gate amplifier will be RD. Okay, so now to determine the gain of the amplifier, so we will apply KCL to the node D. KCL to node D. Okay, so now this is your output current and this is your ID. So both the currents are going out of the node. So ID plus I0 is equal to 0. So here I0 will be equal to minus ID. ID is nothing but GM into VGS. Okay, GM into VGS. I0 I can write it as V0 by RD, because I0 is the current which is flowing through the RD. Voltage is V0, so I can write I0 as V0 by RD and ID as minus GM into VGS. So from this equation 1, we can write this as minus GM into minus V in. VGS will be same as V in but opposite in sign. So this is V0 by RD. So this I can take this to the denominator. This becomes V0 by V in. V0 by V in is equal to plus GM into RD. This is the expression of gain for the common gate amplifier. Okay, so we can solve the problems by knowing the expressions of these input impedance, output impedance and gain for the amplifier circuit for the any given value of RD, GM and so on. Fine.